Welcome to this video. We will start learning about Altair, a visualization package in Python. Altair is a declarative visualization package. Being declarative, Altair provides high-level ways for developers to create their charts based on specifying multiple ways of mapping the data to different graphical marks and encoding channels. The alternative philosophy of visualization is what we call imperative or procedure visualization packages. These packages provide a set of predefined charts that developers can customize. A declarative visualization package, on the other hand, provides much more freedom to create different kinds of charts based on these basic primitives. It has a bit of a steeper learning curve, but it's very powerful once learned. Most modern visualization packages, including R, ggplot2, including also popular tools such as Tableau, uses the grammar of graphics. So the purpose of this introduction is to overview the basics of Altair and to talk about the grammar for graphics, specifically graphical marks and encoding channels. So let's start with the basics. Altair doesn't come pre-installed with Anaconda or popular Python distribution. We need to install it for ourselves. So we need to run this command only one time to install the package. Once the package is installed, we can delete or comment out this cell from the notebook. Once the package is installed, we need to import it, and it's usually given the alias ALT. This line indicates that we are rendering the charts, the graphs, within the notebook. If you're using JupyterLab, you don't need this directive, but it's needed so the graphs show up in the notebook properly. We will start by using this simple example. This is a hypothetical data set about precipitation in different cities in different months, in 3 different cities in 3 different months in the US. We're creating the data frame here, and as you can see here, the data frame has 3 columns. This data frame is an example of what we call a tidy data frame. A tidy data frame has columns that correspond to variables and rows that correspond to observations. Altair expects a tidy data frame. If the data frame is not tidy, we need to transform it first to ensure it's tidy. In this example, each column maps to a variable, city, month, and precipitation, and each row to an observation. And we have 9 total observations. Well, let's start with the fundamental. We're going to start with the chart object. Each figure, each plot, is internally stored as a chart object. We need first to create the chart object by calling the function chart and passing the data to that function. Now the chart object that this function returns is not rendered. It doesn't do anything. It's basically just signals our intention to do further things to create the chart. If you try to see what's inside chart, you're going to get an error first because there are not enough specifications to render the chart. But it's going to tell you that, well, it's basically a chart relying on this data. So the first step is to create the chart object and pass the data frame to the chart object. Next, once we have this chart object, we can start specifying how we want to create our visualization using the grammar of graphics. There are 4 essential components in specifying the visualization, the figure: the marks, the encodings, the graphical marks, encoding channels, data types, and data transformations. We will talk today about graphical marks and encoding channels. Graphical marks are basically the geometric object we want to use to represent the observations. So a point, for instance, is a graphical mark, a circle is a graphical mark, a square is a graphical mark. So there are different graphical marks that Altair provides, including, in addition to what I mentioned, lines, bars, ticks, and others. So those graphical marks are used to map, to represent observations in the tidy data frame. What I'm going to do here, I'm going to specify a graphical mark by using the function called mark and the graphical mark I want to use. Let's say I want to represent this, to use a point as a graphical mark. Well, then I can do chart.makePoint. And as you can see here, I'm seeing something. We're getting something in return. What this is basically another chart object. I can actually save it in a variable and see what's inside it. It's another chart object. But this chart object, in contrast to the first chart, has enough specification that it can be rendered. Now, the rendering itself is not very impressive. We only see one point. So what's the point? Well, this point represents all of the observations in the data frame. In essence, every observation was mapped to a point, and all of the points, the 9 points, are stacked on top of each other, so we only see one point. Before we proceed, let's take a look at using different graphical marks. I'm going to use, instead of using a point, I'm going to use a rectangle here. If I do mark rectangle here and run the code, I'm going to get a square. Again, it's not very impressive, but the idea here is that each one of the observations is now represented as a square, as a rectangle, and all of the rectangles are stacked on top of each other, so we see only one rectangle. But that's the first step. Once we specify our graphical mark, we need to try to provide more specifications to create the figure. Now, the idea of the grammar of graphics is that to communicate a visualization to a human user, we need to use and utilize the different visual cues that the human visual perception system is capable of perceiving. So this is an active area of research, and intuitively we know that our visual perception system can recognize many things, including positions, including areas, including lengths, including shapes, including colors, right? All of these visual cues are called encoding channels. There are not many of them, and we can check the documentation of Altair to see what it offers. So this is something that we need to think about. What's the best way? What are the different encoding channels that we can use in order to communicate our message? Now let's take a look at this example, and we go to the figure here. Let's take a look at this cell. Here, it's basically recreating the figure and using point encoding again. Now obviously I could have shortcut this. I could have done ch chart rather than recreating the chart. I mean, that doesn't make a big difference here because the data is small. If the data is big, probably it makes sense to save it in its own variable. But here I'm recreating the chart. I'm also specifying a point as a graphical mark, and we get these stacked points. Now let's try to differentiate these points. What I'm doing here, I'm specifying the encoding, and I'm saying to Altair, I want you to use the y position, the y axis, to encode the city variable in the data frame. This means that one of the variables, which is city, is now mapped to a visual channel, an encoding channel, which is the y-axis. And you can see here that instead of one dot, instead of one point, we've got three. Essentially, all observations pertaining to Seattle have been collapsed to this dot, New York and Chicago, right? Well, now we start to see more information. Obviously, the whole data is not represented here, but we can tell we have data about 3 different cities, right? We can do a month here, for instance, and we can get 3 different months, right? Again, the idea here is that we are specifying how we want to map our variable to the y-axis in the figure. So now let's try to add more nuances to the figure. Now I want to use the x-axis, the encoding channel of the x-axis, to encode another variable. For the sake of this example, I'm going to encode precipitation, and as you can see here, if I run the code, I get another figure. Here on the y-axis, I have the names of the cities, but the points are not kind of stacked on top of each other anymore. Each one is showing on the x-axis, and the position of the point on the x-axis corresponds to the value of the variable precipitation. So now two variables of the data have been represented here, right? Months is not represented yet, but this is something we can work on if we're interested in representing it. So let's take a look at this cell here. Now this is exactly the same as the cell above. It's basically mapping precipitation to the x-axis and city to the y-axis. The difference here is that instead of using x equals a parameter, we're using a function called alt.x. In this example, they're doing the same, but using the function enables us to provide further options, further parameters that the function takes. Like for instance, if we want to bin our data. This is something we will see in the future when we want to specify further options of the x and the y-axis. We need to use the function alt.x, altair.x, and altair.y. What's nice about the graph graphic is that you can play with the different ways to creating your figure, and you can experiment. So let's do some experimentation here. Let's say, for instance, I want to put months here. I'm going to put x to be equal to the months and y to be equal to the city. And lo and behold, we've got kind of a square with 9 dots, with 9 points here. That's basically telling us that there are a combination of observations in each one of these combinations of city and months. Again, this is not very meaningful here, but it's kind of sort of to illustrate the point that we can freely play with things and see what we get. Like, we can switch the x and the y. I can make my x a city and y is precipitation here, and I get the opposite figure here. As we will see also in the future sessions, Altair provides ways to do data aggregation, data transformations. We will spend one session on this topic, but what I want to show here is the basic concept. Instead of using the variable which exists in the data frame, I want to transform this variable before visualizing it. In this case, say I want to plot the average precipitation per city rather than the precipitation value itself. Now, just to remind you, before putting average, I'm going to get 3 dots in each city because there are 3 observations. Say I want to put the average precipitation rather than the 3 dots. In this case, I can use the transformation average, and this will basically give me 1 observation per city because there is only 1 average. Now, alternatively, I can do the transformation using pandas and plot the resulting figure. So if I don't want to use the transformation in Altair, I can average precipitation using the operations we learned about. I can group by city and take the average. And then I want to reset the index because the data frame needs to be tidy. Each column has to be a variable. The index doesn't count. So that's the average. And I can store this one as df2. Next, I can create a chart and do mark point in code. Obviously, I don't need average here because I averaged my data using pandas. And that will give me basically the same chart. Now you may ask, so what's the difference? I mean, there are some minor differences. Obviously, the label of the axis is much more meaningful here, but we can work on that. The difference is that some of the basic data transformations are supported in Altair. That said, if you want to do something which is really, really customized, you can do it in pandas and then use Altair. Again, we have options, and options are good. We have powerful tools we're working with, and each one of these tools provides ways to transform the data. Okay, so next I want to talk about changing the mark type. So far we've been using the point encoding. Let's do the same using the bar encoding. The bar encoding is used to create bars that extend from 0 to the value of the bar on the specified axis. So If I do the average example again and use mark bar instead of mark point, I'm going to get a bar chart. Let's see it again with mark point. I'm getting 1 point that corresponds to the average. If I do it with mark bar, I'm going to get a bar chart that extends from 0 to the value of that average. This is a horizontal bar chart because y is the city and x is the average. But it's possible to make it vertical. Just switch the two axes here and you get a vertical bar chart. Finally, I want to talk about combining charts. This is so by all means the very powerful feature of a declarative visualization package such as Altair. The concept of combining charts also extends this idea of being able to create a more complex chart by combining simpler and more primitive charts. So let's take a look at this example. This is plotting the average precipitation per month. So I'm getting an average per month, and I'm using the mark line, so I get a connected line. Now, something new also in this example is that I'm using the color channel to map the city. So you can see each line has a different color because we have 3 cities here. If I don't do color here, what you're going to get is one line, which is the grand average in all of the observations. This is another example of using an encoding channel, which is color, to encode another variable in our data. So I save this chart in chart 1. Chart 2 is very much like chart 1, except that I'm using mark point. So mark point will create a chart in which the graphical marks is point, so I get a point per each country month combination. So this point represents the average precipitation in Seattle in April, Chicago in April, New York in April, and so on and so forth. Now from these two figures, I can create more figures. Let's take a look at this example. The vertical line here means I want to put the two figures side by side. So if I create chart 3, which is chart 1, vertical line, chart 2, if I render chart 3, I get the two figures put together side by side. The AND operation, on the other hand, puts these figures one underneath the other, as we see here. Finally, the plus sign will allow us to put those two figures on top of each other. So if I do chart 1 plus chart 2, put that in a new chart called chart 5, you can see that the lines and the points are put on top of each other. So this provides another visual cue to see the location and kind of in a point on top of the line. And obviously this is the start, right? We can combine chart 5 and or for instance chart that we created above and we get, and chart 4, and we get something like that, right? It's not a very meaningful example, but we can see that we can combine many of these figures using these primitive chart combination operators. Another function which is useful is called the interactive function. This basically makes the figures interactive. It also has many options to specify the interactivity. In a nutshell, it basically allows us to kind of pan and zoom the figure live in the notebook. This is a very powerful feature of Altair package because many of them we want to create interactive notebooks that enable users to gain their own insights from the basic figures that we create. Finally, if we want to save and share the figure itself rather than the whole notebook, we have a couple of options. One option, if you click on the 3 dots here, is to basically export as an SVG, which is a vector format chart, or PNG, which is a raster format, a picture basically, that we can then share. It will be downloaded and we can access the file. The other option is to save as HTML, and this will create an HTML file where specified in the directory of the notebook. That HTML file basically contains an interactive version of the chart, which, if the chart is interactive, enables the end user also to experiment with it. So this summarizes the basic introduction of the Altair package. In the next sessions, we will learn more about the data types and the data transformations in Altair.